Die Atlantis ist ein Auslaufmodell, aber sie wird noch gebraucht. 10-mal sollen die Raumfähre noch starten und die internationale Raumstation fertig bauen. Danach ist Schluss und die Atlantis ist die erste, die stillgelegt und ausgeschlachtet wird.
Wir haben einen Fehler gemacht beim Shuttle, dass wir bemannte Flüge und Cargo-Flüge in ein Gerät integriert haben. Und dadurch musste auch die Cargo-Flüge mussten man-rated sein, das heißt für sicheren Flug gebaut werden, was unnötig ist, wenn man nur Cargo an Bord hat. Wir haben daraus gelernt und haben das wieder getrennt.
Die neue Mondrakete der NASA heißt Ares und sie soll schon im nächsten Jahr ihren ersten Testflug absolvieren. Es wird sie in 2 Versionen geben, eine bemannte mit einer Kapsel für die Astronauten an der Spitze und eine Lastenversion. Die bemannte Ares 1 ist schlank wie eine Silvesterrakete, eine Kombination aus bewährten und neuen Elementen. Die neue Generation der Mondraketen erinnert ja sehr an das alte Apollo-Programm. Was wird sich denn technisch ändern?
Auf der einen Seite haben wir alle unsere Unterlagen. Wir wissen heute die Mathematik, die Physik, die Chemie des Mondfluges. Wir müssen nur die Technik neu entwickeln, denn der technische Fortschritt hat uns neue Möglichkeiten gegeben, neue Elektronik, neue Werkstoffe, die leichter sind und zäher sind. Allerdings können wir von dem existierenden Besitzgut vom Space Shuttle her einiges verwenden und da wird Maximum Gebrauch davon gemacht, um die Kosten niedrig zu halten.
Das Maß aller Dinge ist immer noch die gute alte Saturn V Mondrakete. Heute existieren nur noch 2 Originalexemplare, kostbare Museumsstücke, die an die glorreiche Zeit der Apollo-Missionen erinnern. Zwischen 1967 und 1973 sind 13 Saturn V-Raketen in die Erdumlaufbahn und zum Mond geschossen worden. Endlose Startverschiebungen und Pannen wie beim Space Shuttle gab es nie bei der Saturn V. In Zukunft werden Personen und Lasten getrennt ins All transportiert. Die kompakte Ares 5 und die schlanke Ares 1 werden kurz hintereinander starten. Die Ares 5 Cargo-Rakete hat die Mondlandefähre und das Mondauto an Bord. Die Ares 1 bringt die Orion-Kapsel mit den Astronauten. Erst in der Erdumlaufbahn werden beide für den Weiterflug zum Mond verkoppelt. Für die Wissenschaft ist der Mond wie ein offenes Buch, in dem man die Geschichte der Entstehung des Sonnensystems lesen kann. Astronomen wünschen sich Radioteleskope auf seiner Rückseite, um ungestört ins Universum hineinhorchen zu können. Eines Tages könnte der Mond ein gemeinsamer Forschungsplatz der Menschheit werden, wie heute die Antarktis.
Wir Ingenieure brauchen den Mond als Zwischenstation zum Mars. Nicht so sehr, um dann von dort zum Mars zu starten, das würden wir nicht machen, aber um die Technik zu entwickeln, fern von der Erde, die Selbstständigkeit, die die Astronauten eines Tages auf dem Mars brauchen, schon einmal zu versuchen.
Die NASA bereitet sich auf die Rückkehr zum Mond vor, ganz konkret mit allem, was dazugehört. Vom Mondanzug bis zur Kapsel für eine Besatzung von 4 bis 6 Astronauten.
Um das Jahr 2015 herum werden wir wieder größere bemannte Missionen zum Mond durchführen. Unser Ziel ist es, dort für immer länger werdende Zeiträume zu leben und zu arbeiten.
Der Geburtsfehler des Apollo-Programms war seinerzeit, dass man in erster Linie schnell zum Mond wollte, um die Russen zu überholen. Aber es gab kein Konzept, was man dort eigentlich tun wollte. Die meisten Mondastronauten waren tollkühne Militärpiloten und keine Wissenschaftler. Nur ein einziger Forscher, ein Geologe, war beim letzten Apollo-Flug dabei. Nach 6 Landungen auf dem Mond war irgendwie die Luft raus. Sang- und klanglos wurde das Apollo-Programm eingestellt. Alles, was sich während der Apollo-Flüge bewährt hat, soll jetzt wieder zu Ehren kommen. Auch die Landung am Fallschirm, so wie es vor der Ära des Space Shuttles üblich war und wie es die Russen seit 50 Jahren erfolgreich vormachen. Wird es wieder einen Wettlauf zum Mond geben, wie zu Zeiten von Apollo?
Es wird ein Wettbewerbsdenken geben in den Medien, in der Öffentlichkeit. Aber die Politik auf der Erde dreht sich nicht mehr darum, jemanden Angst einzuflößen oder stärkere Muskeln zu zeigen. Damit beweist man ja niemandem was.
Ohnehin ist die NASA nach dem Ende des Space Shuttles auf die Russen angewiesen. Denn für mindestens 3–4 Jahre werden dann auch amerikanische Astronauten nur in russischen Soyuz-Kapseln zur internationalen Raumstation mitfliegen können.
Good afternoon. Welcome to the Post-Flight Readiness Review News Conference for Space Shuttle Atlantis' STS-122 mission to the International Space Station. Here to give us an update on Atlantis' launch preparations is Associate Administrator for Space Operations, Bill Gerstmeyer, and Space Shuttle Program Manager, Wayne Hale. We'll start with an update and then take questions. Mr. Gerstmeyer.
Thanks, John. Today we held the Delta Flight Readiness Review for STS-122, the Columbus flight to Space Station. This was not a full-blown flight readiness review like we usually do, since we'd already done the flight readiness review back in December. But what we wanted to do today was kind of review the work that had been done since December, preparing for flight, to make sure that we've looked at everything and we were really ready to continue preparations and head towards launch on the 7th. So today we went through all the items. We spent quite a bit of time going over the engine cutoff sensor feed-through connector anomaly that the teams have done just a great job of actually being able to isolate where that failure is. They've got a good fix in place that the failure will not reoccur again. It's nice when you get a failure and you can actually have it repeat in a test stand somewhere, and then you can go put in place a fix. And the team's gone above and beyond. They're in the process of almost completed the certification for that new design to go fly. There's a little bit of open work for them to go do there. We also had a couple items on the main engines that came up through routine inspections of other main engines. Again, not really a constraint for flight, but again, it shows the kind of detail that the teams are reviewing and the information they're looking at to go fly. The other things we talked a little bit about was we had, if you remember back on Discovery OV-103, we had a radiator retract hose that had a bend in it. We went and checked yesterday out at the pad on OV-104 to see if it had a similar problem, and it turns out that it had a similar bend in the radiator hose. We need to understand that a little bit more, and Wayne will show you some pictures and describe that to you in a little bit. There's a little bit of open work associated with that. We need to make sure that this hose is going to work in the condition it is, or we can get it tucked into the little stowage container without having a bend in it. We'll go work on that. So there's a fair amount of open work for the teams to do. We'll get together again on Saturday with the teams to kind of review the status of that open work and see where we're heading. So again, we're heading for the 7th of February for launch. And we'll continue to follow the radiator retract hose over the next couple of days. There's some work out at the pad today, and there's a lot of work out at Huntington Beach that'll be done in the next day or two. And we'll kind of reconvene a little bit on Saturday to see if we're still on track for the 7th, or we're still heading towards the 7th. With that, I'll turn it over to Wayne for any of his comments.
Thanks, Bill. You know, we had a great series of reviews running up to this meeting today, and we had a great review today. As you know, we have had an ongoing series of problems with our engine cutoff or low-level sensor circuits, and the team has responded to the possibility of investigating this once and for all to a root cause in just an outstanding manner. We had a multidisciplinary team from a number of NASA centers as well as a number of contractors working together in a unified manner, and we have come to a root cause, we believe, for our problems that we've been having in those circuits. There is a good solid repair or fix technique which has been implemented. We have a lot of testing that's gone on to prove that this this fix is a good fix, does not entail any unanticipated consequences, and will provide us a reliable safety system in the low-level cutoff protection world. So my hat is off to that team. Many people have spent many long hours, and that testing and documentation is almost complete. The work is complete on the vehicle at the launch pad, and we're beginning to implement that fix on subsequent tanks so that we won't ever have to talk about engine cutoff sensors again, which is my personal goal. We have agreed to, as an agency, 3 of 4 circuits working launch commit criteria, which is the design intention for that system. On this first tanking with the new system in place, we're going to watch it very closely to ensure that we really have eliminated the common cause mechanism. And so if there are any funnies that happen, they will be scrutinized very carefully, and we must be sure that we have eliminated this common cause mechanism that could take out multiple circuits potentially. We believe we've got it from all the testing we've done, and I expect when we go tank up the vehicle next Thursday, we'll be in good shape to go fly. I also want to mention that while I was down in New Orleans last week doing a final review of those repairs and that change, I was also able to take part in a review of the redesign of the ice frost ramps, which will be rolling out with external tank number 128, which will be flying a little bit later this year. That has been another outstanding improvement to the external tank, to the safety of flight that will allow us to feel much more confident that we're keeping our crew safe as we fly ascent. We are dedicated to continuous improvement, not only in this area but across the board with the Space Shuttle, so that every flight is safer than the one before, and the last flight will be the safest one of all. As I said before, we did a thorough review across all the elements. We came up with a handful of things to talk about in this Delta Flight Readiness Review. As Bill alluded to, a couple of things we have found through some inspections of main engines, status of some testing that's going forward on some long-term problems that we're trying to solve, and a number of minor issues that really turned out to be benign once we got to the bottom of them. So with the closure of the engine cutoff circuit system, we wound up without much to talk about until yesterday. And yesterday we opened the payload bay doors on Atlantis to prepare for flight. We have a little bit of work to do on the payloads that have been tucked away in the payload bay for about a month and a half now, 2 months. And in doing so, we were prepared to inspect very carefully these Freon hoses, which we discovered we had a problem with one of the Freon hoses on Discovery. And sure enough, when we opened the payload bay doors, we did in fact encounter a problem. Somewhat to our surprise, we thought this was an isolated case. So if I could have the first graphic, we'll show you this picture. Let me describe what you're looking at because it's a rather busy shot. At the top of your screen, you can see the base of the Columbus experiment module. It's actually got a little sticker on there with COL for Columbus. Down below that, you'll see 2 yellow bars with black stripes. Those are called V-guides. Those allow the crew, when they're using the robot arm, to move the Columbus module in and out of the shuttle payload bay if required. And right in between those 2 V-guides, there is a braided metal hose. That's a radiator flex hose. Now, I need to remind you a little bit about why we need Freon loops and radiators on the shuttle. Obviously, all of our electronics, like all electronics, generates heat, and we must remove that heat in order for our electronics not to get too hot and have problems. So we have 2 different circuits that provide cooling through Freon loops. And the Freon itself is chilled down and then provides cooling to the electronics or carries the heat away, either way you want to look at it, which we then either radiate out to space with the radiators when the payload bay doors are open, or through a use of a water evaporative cooling system when the payload bay doors are closed. We were concerned a number of years ago about the potential for having a micrometeoroid or orbital debris, small strike that could put a hole in the radiator tubes because they're exposed to space. So we put an isolation system where we can actually use the Freon loop and still get the function through the water evaporation cooling mechanism without the radiators. We'd rather not do that because we want to turn all our water over to the International Space Station. But that's available to us. But in the meantime, every time you open and close the payload bay doors, these flex hoses that are part of the Freon cooling loop flex. And in this picture, it's probably not so obvious, but if we could go to the next picture, a little bit closer picture, that hose has a little bit of an S bend in it, or if you look at it from the sign, it looks like the Greek letter omega. It's not supposed to look like that. It's supposed to be straight. And so that is not what we would like. That gives the potential for essent vibration or other forces to potentially cause a degradation in that hose. Right now, that hose is perfectly functional. We're not leaking. It's in good shape. It's just kind of bending the wrong way. Fortunately, we have the hose that we took off the sister ship Discovery. We have now good knowledge that we've flown at least 2 flights, perhaps more, with this kind of bend in the hose. And that hose did not leak, and it has been removed from the vehicle and taken to our laboratory, the Boeing Company's laboratories out in Huntington Beach, California, where we are doing a great deal of work to understand whether or not this is a threat to us. Right now, I would repeat again that this hose that is on Atlantis is not leaking. It's just merely bent the wrong way. So we're trying to understand that. And so the engineering team is going to review every day the data from the stress, the thermal, the assent or other vibration analysis testing that's going on out at Huntington Beach. And hopefully, and I think I'm trying to be positive about this, we will come to the conclusion that this is acceptable to fly at least one flight, either exactly like this or potentially having manually straightened this hose out and then flying it. So that is work ahead of us that we must clear before we go fly. However, the teams are working on it very hard. We are here today at Wednesday. We've got a little bit over a week before we go fly. We're going to review over the next several days in the engineering teams, and then on Saturday afternoon, we'll have a management review of where the engineering teams stand. If we are still on a path that says that this hose, in fact, would be good for at least one mission, then we will proceed to fly. And if at Saturday afternoon, if we don't think we're on that path and we have to do something more drastic, potentially replace the hose, then we will pull together the schedules on what that might lead us to do. So right now the crew is trained. I had a nice discussion with the commander of the flight, Steve Frick, in Houston a few days ago. They're ready to go. All the elements report ready to go, and if we didn't have this hose to talk about, it'd frankly be a little boring. So with that, I'm ready to hand it over for questions.
Thanks, Wayne. We'll start taking questions here at NASA headquarters, followed by NASA field centers. Remember to state your name and affiliation, who your question is directed.
Warren Leary, New York Times. For Wayne Hale on the hose issue. In terms of straightening or repairing that, do you have to replace it if you get that far? Can you just go in and tweak it? Is that an option on the table with that one? Then a follow-up on the eco-sensor.
Well, you know, that's exactly the question we got, Warren, is right now, today, this is kind of a late-breaking story. We just detected this yesterday afternoon. So the engineering team is evaluating the various options and don't have the plan yet. That's, in fact, what they've got to put together over the next couple of days. And you have got the $64,000 question is, can we merely straighten this hose and live with it, or maybe not even straighten it and live with it, or do we have to go replace it? And I think we'll have a good answer by Saturday. Since the hose is not leaking now, and the sister hose on Discovery didn't leak through a number of flights when it was exhibiting this behavior, and even though we didn't detect it at the time, I'm feeling very positive that we'll come to a good conclusion on this. But we have to do our work here. The engineers have to do their work, and we want to make sure that we know what we're doing before we go fly this vehicle.
And a second question on the eco-sensors. When the problems last came up, we were talking about extra monitoring, looking at these voltage monitors that would be part of the system. With the problem we think, fixed with the connector, are we still going to do that extra voltage monitoring for each flight?
Yeah, the voltage monitoring is now part of our standard operation, and that does get monitored from the time that even before we start loading the external tank, all the way down to about the T-minus 9 minute point when we resume the count. At that point, if the system's operating without any issues, we would commit it to flight. Now, it's a little bit more complicated than that, but that's the basic story. If we're good at T-minus 9 minutes, we'll go ahead and commit.
Tracy Watson, USA Today, one on eco-sensors and one on the flex hose. First of all, on the flex hose, does it actually carry Freon? I presume, okay, it does. What are the consequences of one leaking? It sounds like there are a number of these. Why is it so important that you not have a leak on orbit?
Well, we need to provide cooling. We have two Freon loops. This Freon circulates, like it does in your air conditioner at home from compressor to evaporator and keeps your house cool. In the same sort of a way, the Freon circulates through the orbiter's cooling system, and it needs to go all the way around the loop to do its job. So yes, it carries Freon, and I have to think a second for the direction of the flow, but in the forward end, I believe it goes from the orbiter into the radiators, and then we go down the radiators, and then at the aft, it comes out of the radiators and goes back into the orbiter per se for the cooling purpose. And again, we can bypass the radiators and use strictly the water flash evaporators if we need to, but we would prefer not to. But in either event, it is imperative that we have a good loop. Either one of the loops could provide enough cooling to be safe. We require two for redundancy, and also for some high heat load periods, we like to have two. So we would not want to launch unless we were well assured that both loops and all these little hoses were doing their job properly.
Okay, thank you. Thank you. And on eco-sensors, if you think you've found the root cause, why is it that you're going with a requirement for 3 of 4? I mean, if you have one that's not working, doesn't that tell you that your root cause maybe isn't correct?
Well, we like to have some redundancy on the vehicle. We have many, many systems on the space shuttle vehicle that have a launch commit criteria of 3 of 4. Now, I will tell you, whenever anything breaks, we always stop and talk about it. But as you proceed late in flight, you would like to have pre-planned what you're going to do, because the time to talk becomes shorter and shorter. So as you get down to the very terminal part of the count, you would like to have it all thought out. And how many of these do we really need? These circuits, like many other parts of the shuttle, are electrical circuits. They have capacitors and resistors and transistors and integrated circuits and wires and connectors, and there are any number of things that might go wrong. Now, typically we get very good performance. Occasionally we will have a failure of a resistor or something. You would hate to have to scrub the launch for a resistor if you could in fact do your job with 3 of these circuits, and that's been the determination in the past. We have 4. 4 provides more redundancy than we actually need. If it really came down to it at launch, if we didn't think we had a common cause that could affect all the circuits, we're willing to go with 3. And that's basically where we are today.
And one more from me, I guess, if I might. Was there any dissent from that 3 of 4 by the crew office or safety or JSC engineering or anyone?
We had a very good discussion at the program review, and there were a number of offices that said they would prefer to have 4 of 4 documented. However, they all agreed that this was an acceptable plan, and nobody actually brought that forward to the agency flight readiness review. I don't believe is an issue. So we're all in agreement at this point.
Go ahead.
One more quick one for Wayne. On the connector in the tank, there was some discussion early on about some cracking in the glass or ceramic as part of this, and it was not considered a problem. How did you resolve that, and is that considered any type of a flight problem in this tank or any other tank?
you know, the way this works is the wires have to come through this aluminum tank, and it's hard to insulate things coming through a metal tank. So we have a standard connector which has been in use for a number of years in the aerospace business, which has got these metal pins that carry the current embedded in a glass matrix. It's an opaque glass matrix about 3/4 of an inch thick. The entire connector is about 1.25 inches in diameter. So you have these pins that carry the signals through this glass, which is encapsulated in a stainless steel outer ring, which gets screwed into the side of the tank. And then we have the wires come up and join these pins. What we had before were sockets that plugged onto these pins, and in fact we still have that on the inside side, and on the outside side the sockets we have now soldered are permanently joined to the pins. So we have eliminated what we think is our root cause, which is contamination and or condensation, ice if you will, getting on those pins as we go through the chill down of the tank. And we believe that's our root cause to these open circuits, loss of continuity in the circuit. As we were looking at this pass-through, which has got the glass and pins in it, we did note cracks on some of these pieces of glass. We've talked to the manufacturer. Cracks are a normal part of the process. We looked back in our records going back to 1977 on these pass-throughs on the external tank, and there have been numerous cracks noted. These connectors have a heritage that go back to Saturn. They're used on other vehicles. We do not believe that the cracks are a major issue. However, since we have been investigating this phenomenon, we're going to do some more testing to, I think, put any lingering questions to bed on whether or not cracks that might be induced by cryogenically cycling this glass to very cold temperatures are an issue. To date, we've done a number of tests. Some of them have been very extreme. And in all those tests, we have seen some connectors begin to leak at very low rates. And we're going to continue to do some tests. Right now, we don't believe we have a safety issue on board the ship. And we're good for the countdown on the 7th. We're going to do a continuing series of tests that I believe will extend a couple of months past this launch in an effort to try to understand this better and make sure that there are no issues at all involved with the glass in this particular connector. Again, it was a byproduct discovery of doing the electrical work.
Okay, we'll now take questions from Johnson Space Center in Houston. Go ahead, Johnson.
Thank you. Mark Carreau from the Houston Chronicle. You know, there's some problems you can fly and address at the same time. In December on the eco sensors, you decided you really wanted to get to the bottom of that. So I'm sort of probing your end of the day thinking on this issue. Was it to deal with the safety? Was it to deal with the delays that are rather substantial, actually, that this equipment has caused? I just wonder what got you to the point where you just really wanted to get to the bottom of this? And I have a follow-up. Thanks.
What I wanted, I'll let Bill talk about what maybe he wanted, but what I wanted was a good sensor system that would provide us the low-level protection that this whole gizmo was intended to do. And I think we have achieved that. All our testing and analysis indicates we've achieved that. We'll go tank it up on February 7th and see how well we did, but I have a high degree of confidence that we have solved this problem, and we'll worry about other systems from this point forward.
And I guess my add would be that we had a potential common cause that could take out all of our sensors, and that would essentially no-op the entire sensor system, and that's something that we had to go fix. So once we had the inkling of the testing that this was showing up on multiple connectors that appeared to be generic, at that point I think it was our requirement to go understand this problem and get it fixed, and that's what the teams did over the time. And then the side benefit of that is once that's now behind us, now that we've soldered the outside, we've removed that common cause, and now we have a system that's really going to operate the way it was really designed to begin with, and so we can start utilizing it and not have it as a problem that lingers on for us.
Thank you. I think I understood there must have been safety and schedule concerns that sort of drove you to deal with this. So I wonder at this point, what kind of pad do you have in your plans to finish the assembly of the space station with 13 missions before 2010? Do you still have some pad in the schedule that lets you do this again on maybe a different problem if you have to, or did this take away some of the margin you discussed in December and even before?
Well, Mark, I want to go back to something you said, and I want to make it perfectly clear that we were not being driven by schedule on this. We're driven to solve our technical problem to make sure we are as safe as our design of our vehicle intended us to be. So we took the time that we needed to do that. And I would point out that taking this time, we have delayed this flight a little bit. The next flight will be delayed a little bit, but the flight after that will be flying back to the same manifest launch date that we've been looking at for some time. So it hasn't really affected the long-term assembly sequence of the International Space Station at all. And I think, again, from my standpoint as program manager, we have plenty of maneuvering room in our schedule to deal with these kinds of problems and not affect the end game, which is to get the International Space Station assembled, provide all the parts and logistics to them that they'll need for the life of their program.
And I would just add, I think we have a pretty robust schedule to get us with the remaining 13 flights accomplished. We have some other options we're looking at to try to even improve that a little bit, put a little more margin in the schedule to help us if we need. And again, I don't overly fixate on that. I don't really worry about that. You know, what Wayne and I have talked about is we're going to take each flight one at a time, work through them at the right pace, and just go fly as we need to go fly. So again, I think we're cognizant of the overall schedule environment, but that doesn't drive us, as Wayne said. We take these flights each one at a time, and our job is to make sure that that next flight is really ready to go, the crews are trained, the space station is ready to receive the hardware, and we're ready to move forward. And if we're not, we'll take what delay we need to take, and then we'll deal with the consequences as we sort it through the manifest.
Okay, we'll now take questions from Kennedy Space Center in Florida. Go ahead, Kennedy.
Yes, this is Marcia Dunn of the Associated Press with a couple of host questions for Wayne. I'm wondering if the Discovery kink toes was as pronounced or as big as this one on Atlantis. When was it discovered on Discovery, and what might be causing this problem?
Well, let's see. Those are all good questions. I haven't seen an exact dimension on the bin, but from the photographs, it does appear to be about the same that was on Discovery. We found the problem when we closed the payload bay doors for the Christmas holidays, which is our normal plan. And I don't have the exact date, but we can provide you with that. It was fairly late in the month of December. And your third part was what, Marcia?
What might be causing this hose to bend in such a way?
Well, that kind of is the question that's before the engineering team, and I frankly don't know. They don't know. They were just beginning to work on it out at Huntington Beach, and now they've got a second data point, and they're off working very hard to try to understand. This goes down into a box that's got some rollers and a spring mechanism to kind of suck this hose down as the payload bay doors close, and it's a mechanism, and clearly something is not lining up in that box properly. So we'll figure it out, but today I don't think anybody knows what's causing it.
And I would add, I think a thing that's encouraging is the fact that it's repeated. We closed the doors on Discovery again at the pad before we took the hose out, and it kinked in about the same location. We've now got the hose out at Huntington Beach. We're able to now have it in a test fixture, and we simulate door closure, and it kinks in the same place. So from our troubleshooting standpoint, what Wayne and I really like is when a failure hangs around long enough that you can see it repeat several times, because then that will allow you to get smart enough to understand what's really going on. When you get a random failure that shows up and then disappears, those are really tough to find and really tough to troubleshoot. So in a sense, there's a silver lining here in the fact that we've got a nice test article out in California that repeats periodically. And with the teams given a little bit of time, I think they'll be able to understand and answer the question that we're all asking is, why is it doing this, and then how can we prevent it from occurring?
And one other hose question is if you need to replace this section of hose, can you do that at the pad, and how long might that work take?
Well, folks have just started to flesh out those options, and I don't know today whether it's possible nor how long it would take, but that's part of the work ahead of us. Again, you know, we're less than 24 hours into this situation, and frankly, I am very optimistic we'll be able to come to a good conclusion and not replace the hose. But if we have to, then we'll develop all those schedules and procedures and do what we need to do, whether it means doing it at the launch pad or taking it back to the orbiter processing facility to do it. You know, if it's not safe to fly, we won't fly it.
This is Patrick Peterson with Florida Today. Is a hose kink a problem that an astronaut might be able to straighten out during a spacewalk? And also, is it possible that you might have to go back to the VAB to replace this hose? Is it a necessity to go back to the VAB to replace the hose?
Let me clarify a little bit, because it's probably not obvious. We tend to jump straight to the end game. The kink in the hose, the bend in the hose, is not in and of itself a problem. But it does indicate that we have potentially overstressed that hose, and therefore it might in the future develop a leak. That's the real concern. Right now, neither the hose that we took off Discovery nor this hose that we have on Atlantis is leaking. That's good. We need to make sure that we feel like it won't leak during flight. The idea of helping this hose go back down in the retract box is principally for the launch phase, because a lot of the vibration and stress that gets put on the hose is done in the launch phase, and we'd like to have it all tucked away properly in its box. On orbit, I doubt that we would send the crew out to do anything to a hose. As a matter of fact, I can say nobody's talked at all about wanting to send an EVA crew out to do anything about the hose, because we think we can deal with it on other ways for the on-orbit and entry part of the flight.
Yeah, hi, it's Bill Harwood with CBS. Two for Wayne, if I could. How to phrase this? You know, the whole context of what you're saying here with the hose and everything you guys have been looking at with eco-sensors really brings to mind that you're a different agency today than it was 5 years ago. And obviously with an anniversary Friday, Wayne, I realize you could talk forever on a question like this, or maybe not at all, but I mean, the question is, can you maybe give us some context about how the agency is different today? Obviously, I mean, just in the context of what kind of work you guys now routinely do to get these shuttles ready to go. Thanks.
Oh boy, that's a big one, Bill. You know, somebody asked me just the other day if I think about Columbia often, and I got to tell you, I think every day about Columbia and how that came about, and how we can prevent similar events as I do Challenger. The Apollo 1 fire was a little bit before my time, but certainly we've studied about it. And I think the really the most telling comment I've heard anybody talk about that accident was a comment that Frank Borman made during the investigation, when he said that the accident was the cause because of a failure of imagination. Nobody could imagine that something that bad could happen, and we clearly missed it. The agency missed it in 1967. I think the same sort of thing happened in 1986, and certainly happened in 2003. And part of what we are trying to do in the great change of culture at NASA and the human spaceflight arena is to reinvigorate that imagination, because if we can imagine what might happen, then we can deal with it, prevent it, what have you, and hopefully avoid a tragedy in the future. So that thought is with us every day, and certainly this time of the year, it's a little bit more poignant. but it's not forgotten the rest of the year either.
This is Jay Barbary with NBC News. Let's say that you are able to get the bent hose taken care of and get off on the 7th. Now you're talking about delaying 123, 124 a couple of months. That would put 123 into April at the earliest, maybe May, June for 124. Then you're looking at, I believe, Endeavour going out for Shuttle, for Hubble, but you still have to have, be Atlantis out and have Endeavour on the launch pad. Could you clarify a little bit about the schedule now, what the probability is with this new problem?
Well, Jay, I think your math's a little off. We have, in fact, agreed to try to launch the next flight on March the 11th. So we will be launching, we'll be working toward that date. And the flight following that would be on the same date that we have been carrying it for some time, which is April 24th. Then we would have a break, if I'm remembering the manifest correctly, until August. And currently we are evaluating a short delay of just a couple of weeks from mid-August to late August, but still within the same month for the Hubble flight. And then the rest of the manifest is basically on track. So I don't see the long duration implication coming out of this this engineering effort that we've had to fix the engine cutoff sensor circuits.
So what's confusing me, you were talking a while ago about a delay. You need at least 2 months, a delay to look at these various things. That's the way I understood you were talking about maybe delaying the next 2 flights. You're staying on for the 11th.
We currently have our internal program, of course it's not official until the flight readiness review, but the shuttle program internal launch date for STS-123 is March the 11th, and that's what we've agreed to with our space station partners and the Air International partners. I would tell you that they're monitoring the launch of the automated transfer vehicle, which is going up from Kourou on a French Ariane rocket, and probably you need to have the space station people or maybe Bill Gerstenmaier can talk about it. That may affect our launch date, but right now from the shuttle standpoint, we are firmly on March the 11th for the flight of Endeavour to carry the first half of the Japanese payload complement.
Yeah, I think this is a very dynamic time in terms of overall launches. You'll see the 28 Progress launch is going to be on the 5th of February at 7 a.m. Central Time, and then the docking will be on the 7th of February at 8:30. That's the Progress vehicle. Then the ATV docking sits, there's 2 windows depending on when they launch, either just in front of the 11th March shuttle flight or a little bit after the shuttle flight towards the end. And so we're kind of just staying fluid with all our partners to watch where the shuttle goes, watch where ATV launch goes, and then figure out the right overall schedule that helps us from a near-term standpoint. So Wayne's right, we may see some movement in the 11th March flight, but that would be to accommodate ATV, and that would be from kind of the overall international aspect that this is the best way to get done what we've got to get done during this time frame. So it's an exciting time for us, and the fact that we're seeing Progress launches, shuttle launches, ATV flying. As we were doing the FRR today, there was the spacewalk going on to replace the beta gimbal out on space station. So we're secretly watching out of one eye, watching the EVA crew go out and change the beta gimbal, and then kind of watching the status come down and see that thing actually operate and get full functionality back on the starboard array was just a great thing to us. And again, so there's multiple aspects of this. It's all interleaved, and we're doing our best to keep watching all the little pieces to figure out the best way to put them together.
Okay, a follow-up question, Tracy?
Tracy Watson, USA Today again. Do you have a feeling for when this flex hose was last seen to be straight and normal? Was that ever looked at on previous?
They are going back to pull all the photographs. We take thousands of pictures and lots of video during the flights, and that question is one that they're going to try to resolve over the next day or so to determine when, or at least whether or not during the last flight it had this kink in it. And So I don't have the answer today. We don't have the answer at the review, but I expect to have that in hand very shortly, tomorrow or perhaps the day after at the latest.
More in the New York Times again. Quick question for Bill. The Columbus module has been sitting out on the pad for an extra 2 months or so. Are there any concerns that this weight has affected it at all, and has it required any additional maintenance or caregiving since it's been out there?
The teams continue to watch the module, and I believe there was an external payload that required a purge, and this payload bay door activity that we did yesterday was associated with removing that purge from that payload. So again, the teams in Florida have done a great job of watching over the payload during the time it was out at the pad to make sure it stays in a flight-ready configuration, and it's in a flight-ready configuration, so it's ready to go to space station.
Okay. That concludes today's news conference. For more information on Space Shuttle Atlantis' STS-122 mission, please visit www.nasa.gov. Thank you for joining us.
At this point, we ran it down and it went right in California.
Hey, slide over this way a little bit more. There you go.
Take your time. Keep quality back. Get the phone there.
Rest it on that lap guide again. Straight back, straight back. Straight back.
Go in okay? Just
went right in.
We're going to look at the back also? No. Ticket?
I saw it right down there. I saw it right there. Until I left you.
Good morning, everyone. We appreciate everyone coming out for our second try here. First try in 2008 for a shuttle launch. We're feeling very good about this opportunity. We'll keep looking at the weather, but we're very happy about the condition of Atlantis. A lot of people have asked me if it's frustrating or difficult for the crew to get so close to launch last time and then have to wait 2 months to try again. But I know as far as for me, I was very happy with the way things went. The eco-sensor problem has been nagging us for quite a long time, and we were actually very pleased that we're able to have it reoccur a couple of times and pull the hardware out, find out what the problem really is, and get a chance to fix it properly so we don't have to worry about it. I'm sure everyone has heard an awful lot about those sensors, but we really rely on them. We use virtually all of our gas just to get up to orbit for a normal mission, like 99.5%, and we can't afford to let the engines run dry because they tend to come apart. So the eco-sensors are a critical safety system that I'm very happy we're able to fix them and feel very confident about them working. Our technicians here at Kennedy and all over the shuttle program, the technicians, the mechanics, the engineers are, I think, the best there are, and they've done just a tremendous job nailing this thing down and fixing it so that we know we can go fly. We've been tracking a couple of little things with the orbiter, but as far as we can tell now, everything's looking just great for this week. So hopefully we'll get to launch later this week and be back right over there, we hope, in about a little over 2 weeks. So thanks again for coming out, and we're feeling great about this week. I'd like to introduce my my pilot, Navy Captain Alan Poindexter.
Good morning, and thanks for having us today. It's great to be back in Florida at the Kennedy Space Center. It's nice to see so many familiar faces, and we're really looking forward to a nice few days in quarantine at the crew quarters, getting ready for the flight. Atlantis looks great at the pad. Payload bay doors got closed up last night, and it looks like we're in great shape for a launch on Thursday. The launch count starting at 4:30 today, and we're just real excited to be back. Thanks so much to everyone here at the Kennedy Space Center for all the hard work you've done getting Atlantis ready for the flight, and we're really looking forward to getting Columbus on orbit. I'd like to introduce MS-1, Mr. Leland Melvin.
Thanks, Dex. As Dex mentioned, one of our primary tasks is to install Columbus, and to do that we need to use the robotic arm, the big robotic arm from Space Station, Canadarm2. I'd like to thank the training team, the flight control team, and our partners up in Canada for getting that ready for us, for getting us ready to install the Columbus and to do some inspection on the orbiter and to have a wonderful flight. Next will be Colonel Rex Walham, MS-2.
It's great to be back here at the Kennedy Space Center. This time we hope to be leaving in that direction instead of that direction. And we put our last 2 months to good use. Thanks to our great training team, we fine-tuned our checklists. The suits and tools are looking good, and we had a chance to get back in the water to practice all 3 spacewalks. And that was a really good practice, and we're ready to go in that direction. Next up is Hans Schlegel, MS-3.
Good morning. It feels really great to be back here. The launch of Space Shuttle Atlantis and the Science European Module Columbus is very, very important for Europe. Columbus is the biggest contribution of Europe to the space station. But not only do we launch Columbus and bring it up to the International Space Station, that also marks the beginning of the operation of a European control center close by Munich in Germany. And for the future decade, Columbus and experiments will be controlled from there. On behalf of ESA and from the bottom of my heart, I would like to thank all the people for their hard work which made it possible to be here and get Columbus into orbit. And especially, I would like to thank all these people for their dedication and their meticulous work who got Atlantis ready again. Thank you very much. Next is MS-4, Stan Love.
Good morning. It's exciting here to stand here in front of all you guys. We'd also like to recognize and thank, though, the hundreds of spacecraft operators who work without much attention from cameras and reporters. the flight controllers and engineers working around the clock in control centers across the country and around the world in support of human space exploration. And next to speak is MS-5 Leo Ayarth.
Good morning, everybody. I'm happy to be back here and try again to launch Columbus and go for what is still a long-duration mission for me, about 2 months. I'm ready, more than ready now, and I'd like to thank, like my colleagues did, all those who have been working hard over Christmas and the New Year to make Atlantis ready for this flight. So I hope that February will be the month of Columbus. Thank you very much.
Have a good flight. All right. You still got a picture of us. I do.
Good afternoon, everyone. This is the pre-launch press conference for STS-122 with Space Shuttle Atlantis and the Columbus Laboratory. Here to discuss our pre-launch activities today is Leroy Kane, Management of Launch Integration and Chairman of the Mission Management Team, Doug Lyons, the STS-122 Space Shuttle Launch Director, Alan Thurkettle, the International Space Station Program Manager from the European Space Agency, and U.S. Air Force Lieutenant Colonel Patrick Barrett from the 45th Weather Squadron. And we'll begin first with Leroy Kane. Leroy?
Okay, thank you. Well, it's great to be back here at 2 days before launch again. We, as you know, going into the holidays after our December attempts, we set afoot to work on the engine cutoff system, and we've done that. In the meantime, we had a few additional new issues crop up, and the team worked through those as well. We got back from the holidays and hit the ground running, and dispositioned those items while we had the engine cutoff sensor system work in progress. That went through several phases, and ultimately, as we reported to you, I think, last week from out of our flight readiness review, we converged on a solution that involved some changes to the hardware, the external connector primarily, and we went through a series of tests, analyses, and a full battery of engineering rigor to certify that new system and to implement it here on the tank that we have out at the launch pad. The team has just done an outstanding job working through that problem, and I know we've reported to you to some level of detail on that. In the meantime, as I mentioned, in working that problem, we did have a couple other issues crop up, and so at the time of the flight readiness review, there was some open work associated with those issues. One of them was this radiator flex hose problem that we discovered. And so the team had to work through that, and so that's what we've been focusing on for the last week. There were a few other minor, relatively minor items that the team worked through as well. So the idea today was to come in and review our progress on all those items. So we did hold the Launch Minus 2 day mission management team review earlier this morning, and we reviewed our progress on any open issues that we had coming out of the flight readiness review. In the intervening days, we did have a number of program level meetings, and yesterday as well as on Friday we had a program board to review the status and the readiness to go forward on a number of those issues. We resolved all those issues to the satisfaction of the program, and so we dispositioned those at the Launch -2 MMT meeting today. We also, as we always do, we went around the room to see what other issues there were out there that the rest of the team might be working, and we really don't have any significant issues in work as of now. There's a couple of items, as there always are, that are brand new, and folks will go look at and determine if there's anything to be concerned about. But we don't see anything right now as we go forward here to get ready to launch on Thursday. So the team has just done an outstanding job to get us back to this point. We feel very confident in the system that we have out there at the launch pad from an eco sensor system as well as all the systems standpoint. And as we talk through all of the associated issues that we worked from the last time that we were here, as we talked through and summarized all those things today, I think the team feels like we're in a very good place to go fly on Thursday. So we'll no open issues or constraints outstanding to be able to go forward and launch on Thursday. We have a tanking briefing at 4:45 a.m. Eastern Time on Thursday morning, and so we'll look at the weather, and we'll look at the vehicle, and we'll look at the ground systems, and we'll make a decision about tanking in preparation for a launch attempt on Thursday. So with that, the team is in great shape, and we're ready to move forward, and it was a good MMT review today. I'll turn it over to Doug.
Okay, and thank you, Leroy, and hello, everyone. As Leroy has mentioned, it's really been an outstanding effort to get us back into this position. Folks have been working around the clock and over the holidays, and we are in fact back in the launch countdown. We picked that up yesterday afternoon. So again, just it never ceases to amaze me, the commitment and dedication of this team and what they're able to do. And so personally, it's really an honor to be part of this team, and frankly somewhat humbling. As I said, we picked up the count yesterday afternoon. First things we do when we pick up the count is we go into a series of avionics tests and checkout, and we perform those through the evening with no issues picked up. Currently, we're clearing the launch pad, and we're going to go into our fuel cell tank servicing, where we load our liquid oxygen and liquid hydrogen tanks, and that should run for the better part of the day. We're not working any issues. We haven't picked up one piece of what we call IPR and problem reports. It's been a really clean count. We're hoping it'll stay that way, of course, and we have some confidence that it will. So really nothing to report other that we're on our timelines, and the countdown's going really well. I did have the opportunity to greet the crew yesterday when they arrived, and I can tell you they are in very good spirits. They're very excited to be back in Florida, and I think they're very anxious to get to launch day and get in orbit and start their mission. As far as the launch team is concerned in the firing room, they're doing an excellent job with executing the launch countdown. You know, they're focused on the job at hand, and will continue to stay that way. And we're looking forward to getting Atlantis into orbit on Thursday. And of course, we're all thinking that Thursday's the day, regardless of what the weather guy might tell you. We think Thursday's the day, and we're certainly looking forward to it and ready to go make it happen.
All right, thanks, Doug. And now to Alan Thurkettle, the International Space Station Program Manager. Alan?
Thanks very much, and good afternoon to everybody again. We're very pleased to have participated this morning in the successful L-2 Mission Management Team meeting. As you've already heard, the meeting was pretty smooth, and we're happy to see that that's going on. I'd like to say from an ESA point of view that we're very confident and very comfortable with the design fixes that have been put into the ecosystem since the December problems. And we're very happy indeed to see that all the Delta qualification work on the fix has been successfully done. There are no open paperworks and no, well, maybe it's okay, maybe it's not type of things. It seems very, very solid indeed, and we're very comfortable with that. We've tried to have Columbus looked after nicely since December. It's been covered up and carefully put under wraps, and nitrogen purges on the external payloads. So we're happy with that. We closed it all out over the last couple of days before the payload bay doors were closed out, of course. And we've taken the opportunity to change out the biology samples that were in our flight deck, so that we've got good fresh biology to take up, not 2-month-old stuff. So, in a nutshell, the module, the experiments, and the European team are all very, very ready to go, and we're looking forward with great excitement and great anticipation to Thursday. And in the nature of these conferences, we always leave the good guy till last. So I guess it's the time for the weatherman to tell you what it's really going to be like.
All right, Colonel Patrick Barrett from the 45th Weather Squadron.
Thank you. What we are looking for is there is a cold frontal system which is in through the mid-central U.S. down through Texas. We're continuing to watch that. We are looking forward to come across the U.S. and to be to our north in through central Florida and northern part of Florida on launch day. Main concerns that we have right now are for cumulus clouds in the area, for showers, and also for anvil clouds of anything that may develop to our northwest. With the winds coming from that direction, that would be a concern for us also for launch day. And we currently have a 60% chance of weather prohibiting launch. The rest of the TAL sites and AOA sites still look good for their weather, so the primary concern and what we're monitoring is going to be right here at KSC.
Thank you, Patrick. And we're ready now to take questions. Please give your name and affiliation when the microphone comes to you, and we'll start right here in the front with Marcia.
Marcia Dunn, Associated Press for Leroy. What is the team's strategy in case when you open up the payload bay's doors in orbit, the radiator hose goes into another bend? What happens?
Let's see, Marcia, the issue that we have seen on this radiator hose is one where in the door open position it's not an issue because the hose is being pulled and stretched while the door is in progress opening, and then even once it's open there's nothing else for the hose to do in terms of going further back in the box or coming further out. So it's in the extension direction, if you will. So that's a good configuration. The issue that we've seen is when we close the doors, the hose is not wanting to feed itself back into this containment box the way that it was designed to do, and it goes through some rollers. It's fed through, I'm sure you've seen some pictures, and so there's a couple of different things that could be happening there in terms of binding or rubbing or changes in stiffness to this hose. It's a hose that has a convolute on the inside, and essentially it's like a bellows. So if it's moved in a certain direction in a certain way, it has a propensity to have some memory, if you will. And so in this case, what that means specifically is there is a chance that when we go to, after we open the doors on orbit, at the end of the mission we go to close the doors, that there is some likelihood that it'll go back into this, quote, omega bend configuration. It's in the omega bend configuration that we have the issue, and the issue is one whereby that part of the system was not designed to be configured in that tight radius kind of situation. The hose has obviously been in that configuration for some time when we discovered it while the doors were closed, and it's not leaking, it's not broken, it's not failed, the hose is working fine, but now because it does have some memory, there is some propensity for it to go back into that omega bend. In that configuration, which is not the design to configuration for when the doors are closed, then the concern becomes, well, what are the environments? Vibrations, loads, stress, and whether or not the hose can handle those environments in those various flight phases. So that was the problem that we looked at with the hose in totality. And the way we worked through that was that we said, well, for the pre-launch and the ascent flight phase, if we can get the hose with the doors closed, if we can get the hose configured so it's back down, fed back down into this containment box the way it's supposed to be, that's a much better configuration. That's an as designed to configuration to go fly with, and then we don't have the issue with the ascent and loads, vibration loads, and stress. And so the team worked very hard on figuring out a way to go do that, and they were able to accomplish that on Sunday when we did door closure. That helps us out because the environment that the hose is going to fly in now, and the configuration that it's going to fly in, I should say, for the ascent environment is pretty much as designed to. So the accepted risk that we have in this case is at the end of the mission, really, when we're going to go close the doors again. And so we had to look at it from the standpoint of planning on having that omega bend repeat, and looking at that from a test and an analysis standpoint to determine whether or not that was an acceptable risk. In other words, let's assume that it's going to omega bend again, and let's assume that the environments in the flight phase of deorbit and entry are going to be to the extent that we know from an analytical standpoint, we can look at those things. So we did a number of things to get comfortable to prove to ourselves that that was an acceptable risk, not the least of which is we took a similar hose off of the 103 vehicle, which was known to have been in this omega bend configuration. It's sort of the fleet leader, if you will, in that regard. And we sent it out to Huntington Beach, and it's still being tested from a cycle standpoint to see if we can make it leak, and if so, how long is it going to take to make it leak. So the testing and the analysis that we've done supported a conclusion that from a fly-as-is standpoint, first of all, for the ascent environment, having the hose back in the box, and then realizing that for entry we expect an omega bend to be there. And if it's not, well, then that's great because that's better. But kind of the worst scenario being that having the omega bend in there, and then what are the risks associated with that? What are the chances that it's going to develop a leak? And if it develops a leak, is there a chance that it's going to have this burst before leak kind of failure mode? And we worked our way through all of that, and we believe that it is a leak before burst scenario. There's some automated software while we're in the on-orbit phase of flight that if it begins to leak, it'll close the valve in the system and isolate the radiator from the Freon in the Freon loop, and we'll essentially take that part of the broken part of the system out of the loop, and thereby not lose the Freon loop, just lose the radiator. And so that was important to us, as well as the testing and analysis that showed that we think we're a long ways from having a leak develop in this particular hose that we have on Atlantis. So it's a concern for door close. It's a concern that we've looked at from the standpoint of risk mitigation. We have the hose in an ascent configuration that's near designed to. We have the ability to mitigate the risk further on entry by isolating the loop if we choose to do so. And right now, going into launch, our end of mission plan is to consider isolating that radiator for deorbit and entry. And we have a sufficient amount of, a fair amount, I would say, of test and analysis that supports the hose will support at least one mission in this configuration. And our current plan is that we'll look at changing out this hose after we fly because we can in the next flow of OV-104. But we're certainly good for at least one mission on this hose.
Other questions?
Okay.
Marcia?
Could I just follow that up? What would happen if it burst, before any evidence of leakage? Is that any kind of a hazard to? And also, do you have any concerns about closing the doors tightly if it's all bent up as it has been?
Yeah, there's no concern about closing the doors tightly because of the limitations in the hose system. It can only be so long. It can only create so much interference. So we don't have a concern in that regard. With respect to a burst before leak kind of situation, what that means to us, if we assumed that that's what was going to happen, is we would lose that Freon loop, because in a burst kind of scenario, the gas, the fluid leaks out so fast that we cannot isolate the system either by taking the flight control team or flight crew intervention, or by the automated software, which when it detects a leak of a certain size, it'll close the isolation valve and then we'll bypass that radiator. So A burst before leak scenario means fast leak, and fast leak means certain loss of the Freon loop, and it's a loss of redundancy in our ability to keep the right level of cooling on the vehicle for all of our critical systems. So that is a worst case failure scenario from the standpoint of this, and we certainly don't believe we have any reason to think that we're have a risk of a burst before leak scenario, and we looked very hard at that, and it was important for us to determine that.
The loop, so to speak. Would you have to land if that happened, or could you go up, like if you were facing a weather wave off, would you have to land somewhere, or could you just stay up an extra day and open the doors back up and just live with this burst loop?
Yeah, it's one of those situations where the cooling system is critical to the survival of the vehicle in a flight condition. And so when you lose cooling, suddenly you're on a timeline to get to the ground that's very constrained. Okay, you got to get to the ground fast. If you lose cooling because you lost Freon loops, that equates to a certain level of contingency in terms of how much time you have to get to the ground before you run into a problem and your systems start failing. If you lose cooling because of cabin fans or water loop failures or other parts of the ECLSS, the environmental control and life support system, those all equate to different kinds of numbers because of the indirect impact that they have on the overall system and the ability for your avionics to survive. Okay, in this case, the Freon loop is one of two, okay, and so in a large sense it's redundant. However, the mission rules that we go by in these cases are that in this case, we would be in a PLS, what we call a primary landing site situation, and we would take our next opportunity to land at the primary landing site. And the reason that we do that is because if in the intervening time, before we're able to get to a safety orbit and landing, we lose the other Freon loop for some other failure, then you're in one of these time-critical emergency landing situations because you don't have the time to stay on orbit anymore. So it's a loss of redundancy. We could stay on orbit for an extended period of time, but we're exposed during that time to the next failure, in this case the next worst failure of the other Freon loop. And so we'll try to minimize that window of exposure if we should have a failure like that, whether because of this hose fails or any reason that takes a Freon loop.
Jay?
Jay Barbary with NBC. A two-parter here. What's your current thinking, if all goes well, Doug, or Leroy in orbit, about extending this mission? I believe I read earlier that it wasn't going to be extended, but are you thinking about that possibility? And also with the Columbus going up and the Japanese lab following, what's the current thinking on number of crew members up there permanently? Is it going to stay at 3, or are you going to expand?
Let's see. Let me take the last question first. I don't know that we've changed our thinking on the numbers of crew members as a result of this next mission or the following one. So, of course, we'll continue to evaluate that, and there may be a strategy that we go to with the partners, but if we've made a change to our thinking in that regard as of today, I'm not aware of it. So I can't help you, and I could ask for our International Space Station program or their friends and partners to try and get you an answer. Your first question?
Possibly extending the mission.
Yeah, no, we're at an 11 plus 1 plus 2, which means we have the ability going in from a launch, where we are launch standpoint, of extending 1 day from a capability standpoint, and then 2 days at the end of the mission for landing. So right now we're not planning on extending. As you know, our posture has changed a little bit from an onboard International Space Station standpoint in terms of what they need us to be able to do while we're there. We're looking at executing 3 EVAs on this docked Space Shuttle Space Station mission, as opposed to 4, which is what we were looking at before. And so before we had some desire to extend and get the 4th EVA. We're not in that same posture anymore. Now, that's not to say that something else couldn't come up that would cause us to want to extend that 1 day. and if so, we have the capability to do so. But it's not currently in our plan.
Originally, in the concept of the station, you were going to have as many as 6, I believe possibly even 7 crew members on board, but you revised and went back to 3, and I think that's where you left it. But is any thought, maybe our European people can tell us, any thought being given to asking for more members on board with Columbus up there, the Japanese up there?
Yes, there's more than thought. It's the program's baseline that by May of next year, the permanent on-orbit crew will be 6. The work that's going on between now and next spring, in fact, spring of next year, is to bring the configuration of the station up to the point where we can have a 6-person crew on orbit, which means having permanently 2 Soyuz rescue vehicles on orbit, and that's scheduled to occur in May of next year, and that's been the plan for quite a long time now. So if you like, independent of Columbus and Kibo going up in the next few weeks, that's the program. But part of the rationale for the extra crew people being up there is because we've got all that extra science capability that Columbus and Kibo bring to the station. And as far as the current mission is concerned, I think Leroy has answered just perfectly as far as the orbiter program is concerned. But the number of days that the shuttle is on orbit and the number of days that means that the shuttle crew are on orbit is a very, very precious resource. And if we find that that there is sufficient power, sufficient consumables and all this kind of thing to extend the time that the crew are on orbit to help further the commissioning of Columbus and to get ahead from the stage activities, then certainly the station people will be talking with the shuttle people to see how we can make use of those available resources.
But are you saying you're jumping from 3 to 6, or are you increasing by 4 or 5 next year?
We're jumping from 3, which is the current load, and we'll stay the current crew until May of next year, and then it will go from 3 until 6.
And then we'll have 6 people after May next year.
Correct.
All right, thank you, sir.
All right, let's go back here to Bill.
Bill Horowitz, CBS for Alan Thurkettle. Obviously, Leopold Eihart's mission is being compressed by a few weeks anyway, but I really want to get to what you were just talking about, the mission extension, and it's my understanding you are going to do that if the power is available for Columbus activation and commissioning. What sort of things would an extra day bring to you in the context of Columbus if you get the extension? Thanks.
Well, we'll be looking, if you like, we've got a plan B and we've got a plan C for how we conduct all of the mission. From the station point of view, and specifically from Columbus's point of view, we would like to get as many days on orbit as possible. The task of Leo and indeed the rest of the crew on this mission is to install and attach Columbus, install and attach the external payloads, and then commission Columbus, which for us doesn't mean wringing out every single subsystem that we've got on orbit, but in fact it means bringing up the payloads that we've got on board, and hooking those and connecting those to the scientists and the principal investigators on the ground, because we want the iterative science between the ground investigators, the crew, and the Columbus itself to be the demonstration that Columbus works, and that's what we're trying to do on this mission. And in that, every crew hour is very precious indeed. Now, we have a nominal plan that assumes that everything works properly, and then when item X doesn't work properly, then we go to the first workaround, and all of those kind of things are put into place. And I can't give you a specific example of if we get an extra day, then we're going to do this, that, and the other. If we get an extra day, we've got the opportunity to do more of what we're trying to do. Now, originally, stage 1E was going to be, if I remember rightly, 12, even 13 weeks, something like that. And yes, it's been compressed. We've rung through the timelines of the activities that we're going through. And I hope I'm not saying things out of school when I say we've also taken account of the fact that the crew that's currently on board there is just performing out of their socks. They're just a fantastic crew. They're doing incredible work at a rate that the dreamers wouldn't have come up with, let alone the planners. But that's the way it's going, and we're kind of hoping that that'll rub off on the shuttle crew and on Leo and Hans when they go up as well. And they've been told that they better do as Peggy tells them, because that's the way it works on station. And I think that we'll get our commissioning plans done even within a 6 or 7 week period of time while Leo is up there. So we're fairly optimistic on that, and I think it's going to go well. Yeah.
Mark? Mark Carreau from the Houston Chronicle. I had a couple of questions. The first one has to do with the eco sensors, and sort of if you could kind of walk through what you expect as the tank is filled Thursday. Do you expect them to all of them to ring in wet, and then are you going to run through the usual series of tests to see if they're wet or dry? And when you get down to T-9, what do you expect to see based on the repairs and the testing that you've done?
Okay, well, let's see, Mark. I'll start off, and I'll hand it over to Doug, and he can give you some more of the details for the actual tanking process. What we expect to see is the system work perfectly normally, and we expect to see completely nominal results when we, first of all, cover up the sensors and they're initially wetted. And then as we continue on from there, we'll have our normal sequence that we've been using for a few flights now in pre-launch, where we send the simulated commands, and that gives us the ability to understand if, while they're covered up wet, as we continue to fill the tank, if they should have some kind of failure in the circuit that results in going open circuit or any other failure mode. So it's to the failed wet condition or open circuit. That's been the troubling failure mode that we've dealt with, and that's been the one that we saw with what we believe now to have been an issue with this connector. So we'll do our normal sequence in terms of filling up the tank and covering the sensors, and then once the folks on Doug's launch team get to the right place in the sequence, they'll send the sim commands, and then the team will monitor, and if they see any failures, we'll respond to those per the pre-planned contingency procedures. But I expect to see a completely nominal system. I have very high confidence that the resolution we came to here on this system is very solid. I think we found the place where we were having the problem in this connector, and we resolved it by soldering the pins into the sockets. And so I feel very good about that. And so when we get to T-9 or L-9 and come out of the hold and count from 9 down, I expect to see the same thing. And we have some differences in our insight as we go through the count. But all the way along the way, in terms of the data that we're able to see, I expect to see perfectly nominal performance. Doug, on the tanking?
Sure. You all might be aware, but we're going to pick up tanking at 5:20 in the morning. And what we've found is that these sensors are sufficiently wet, covered with the cryos, about 40 or so minutes in. So I would say somewhere between 6 and 6:30, we'll start our first test. And the way we do that is, just to add a little to what Leroy said, is, we've got the 4 sensors and we're watching them, and they'll send sequential sim dry commands to each of the sensors. So we'll be watching, they'll send, and it's an automated routine they go through, but a command will be sent to take the first sensor dry, and we'll see it go dry, second, third, fourth sensor. And then they'll leave them in that state, and then let them all go wet, and then we'll go through and take them dry again. And then we leave them dry for a period of time through the count as we're filling the rest of the tank. It's a 3-hour tank process to fill the tank to its entirety. And through this count, again, we'll leave them dry, but then we'll go through and run the test again. So we go through that a few times during the actual tanking. And as a matter of fact, our last test is in the T-9 minute hold, and we'll go through the routine, and that's probably 20 or 30 minutes of full time remaining. So we do it fairly early in the 9-minute hold, and that'll be the last verification of the health of the system. And then of course our folks monitor that down to 5 minutes for our voltages. We've got 2 ways to monitor the health of the eco sensors. One's with voltages, and then the other is discrete, wet or dry. And we watch those for dry commands all the way down to 31 seconds. So we'll be keeping a close eye on our ecosisters. And also, as Leroy mentioned, we've got pre-planned troubleshooting plans and contingency plans that we've got on the shelves and we're ready to go implement should we have to. But again, we don't think there's really any likelihood at all that we'll have to worry about that for this countdown.
Thanks. And a question, please, on a different topic. If you recall, can you tell us the estimate on contingency support aboard the space station and the target date for an emergency mission if it was required?
Let's see. That was one of the actions we had coming out of the FRR was for the space station program to recompute the contingency shuttle crew support capability, and they reported today that it was at 69 days from a CSCS capability, and I think Doug's got the 30, how many days of launch on need?
Yeah, our capability here on the ground to process 105 and get it ready for launch would have it launching on March 11th, and that equates to about 33 days from 104's launch to when we'd be able to launch the rescue mission. So obviously we're well within our capabilities.
Essentially twice as much CSCS capability as we need if you look just strictly at those two numbers.
Mike Sinan, WDBO. Do you have additional pressure put upon you at this level because of the length of delay that we're talking about here? And if so, how does it manifest itself, especially given the type of schedule that you're trying to come up with over the next year?
Yeah, no more pressure in this situation than what we always have. We've been given a mission to complete the station assembly and the associated tasks, and we believe that we can still complete that mission. And there will be a point in time if we had enough problems and enough delays where that wouldn't be true. We're not there, and so we're still able to complete the manifest that we have in front of us. It's still our full intent to do that. We certainly intend to complete the missions that we have on the manifest, both this fiscal and calendar year, and we see clear to a very a good way for us to be able to go do that at this point. It's the challenge is in reworking and replanning in the process of executing. So, but that's a challenge that this team is very accustomed to, and in fact, I would tell you that it's one of the things that the team excels at. So we seem to be able to find a way to work through these problems and to replan in a way that allows us to continue to execute and move forward. So no additional pressure in this case. We're really glad to be where we are today. It took a lot of hard work to get here by a lot of folks. And so I hope that we can reward ourselves and the team with a good launch on Thursday, and that's what we're looking forward to, and that's what we always look forward to.
Do you have any kind of sense of what the cost is when there's this length of delay?
We work on marginal costs, and I really couldn't tell you in this case what the cost is.
Any further questions? All right, Bill, a follow-up?
Just one, just make sure I understand what your LCC is on ECOs. I mean, if one goes south, you're good to go, but if two, is that an automatic scrub?
Yes.
Period. Okay.
Yeah. Well, what I would say about that is what we have put in place from a launch commit criteria standpoint is we can go fly safely with 3 of 4 functioning LH2 engine cutoff sensor circuits. In that case, however, the one failure that we've suffered, we need to understand it well enough to be able to say that it's not potentially a generic problem, or it's not some problem that could somehow be associated with this failure mode that we think we just fixed. Okay, so if the one failure that we see somehow potentially indicts the failure mode that we believe, that we fully believe and have high confidence that we just mitigated with this new connector hardware that we put in place, then we're not going to be go to launch in that case. But if it's a problem that's associated with an MDM, a multiplexer card, or some other part of the system that we can positively identify that is not pervasive to the rest of the system and would not indict this fix that we just put in place, then from an overall safety of the system and confidence in the system to go fly standpoint, we've said we're good to go with 3 or 4, but it has to be in those circumstances.
And again, your question was 2 of 4, and the program's given us clear direction on our LCCs, and so we would be no go at that point. And of course, we go through our troubleshooting and try to get as much data as we can, but we're done with 2.
Marcia?
Marcia Dunn, AP for Mr. Thurkettle. How many Europeans are returning as part of your delegation this time? And how difficult has it been for your agency to have to wait 2 extra months since Columbus has been waiting so long even before?
Let's take I'll take them in order. I think around about 300 people are coming across this time, 320, something like that. Until they all get on the planes, we won't actually know. But it's a good contingent, but it's not quite the same size invasion that we had in December. What has it meant to us to wait for the 2 months? Well, we've got Thursday to look forward to this week. If we'd launched in December, we wouldn't have anything to look forward to on Thursday. So you have to take the positives on these things. We've indeed waited a long time for this launch, and it's just going to make it all the better when it gets up there and it works. So we know the business that we're in. We know the people that we're dealing with. We know the systems that we're dealing with, and it's terribly important for us to fly. But it's even more important for us to fly safely, and that's always been the line that we've taken. It would not have been prudent to fly in December. The right decisions were taken at the right time. Hopefully on Thursday we'll get through and we'll get the mission that we've all been looking for.
How many days before you can declare that Columbus is in perfect working order?
I used to be an engineer, so never is the answer to that. But the commissioning plan that we have will know to the point that the thing is really working pretty well after just a few days, and after 2 or 3 weeks we'll be in pretty good shape. Round about 5-6 weeks we'll start to get some real payload data coming out of it, and we'll probably therefore have 3 parties on the way.
Jay?
For Mr. Thurkettle, you're talking about going to 6 after May of 2009. Once they get Orion flying, they can fly 6 to the space station. It can stay there for 6 months. So you could, in theory, fly the whole crew up. Orion sits there and waits until it comes back, or what role will Soyuz play then? Have you gotten that far ahead once that Orion is online?
Well, I think that's a question you ought to be asking the NASA people. We're not running Orion or anything else. But in principle, if Orion is available at that time, it's an alternative scenario to the Soyuz. What it's going to be used for at that time, how the operational manifesting is going to occur, is something that I think you ought to ask the NASA Orion people about.
Any further questions? All right. Well, in that event, our next briefing is going to be the countdown status briefing tomorrow morning at 10 o'clock. Thank you. Good afternoon, everyone. This is our briefing on the Columbus Laboratory and the Automated Transfer Vehicle. Here to talk about these 2 things today with us is Alan Thurkettle, the International Space Station Program Manager for the European Space Agency, and Michel Tognini, head of the European Space Agency's European Astronaut Center. And we'll begin first with Alan Thurkettle. Alan?
Thank you very much, George, and good afternoon to everybody. It's good to be back here again. We were in the same situation in December of last year, But of course, if we'd launched in December of last year, we wouldn't be having so much fun this week. So we're looking forward to a good week this week. I wanted to concentrate the presentation this afternoon a little bit more on Columbus and ATV, and a little bit less on the generic things that I'd mentioned in previous presentations. But just to recall exactly what in total we do on the station, in 1995 our ministerial council approved a participation in the station that included both a development program and a nominal 10-year operations program as well. And the content of that program included the Science and Research Laboratory Columbus, which is going to hopefully be launched tomorrow. It included the payload facilities that fit inside Columbus. Included the automated transfer vehicle, which I'll tell you a little bit about today, which is going to be launched on Ariane 5. The program itself included the price of the launches of those vehicles as well, and it included also the development of ground segment and an operations preparation for the missions that were to come. I emphasize the operation side of it because in Europe we've operated lots of satellites in the past, but before ISS we've never really operated our own human-rated spacecraft, and that's quite a departure for us. The program also included astronaut work, flights and training in preparation for the operations. And included utilization preparation as well. We wanted to establish a program such that once Columbus was ready to go up, we would have science and utilization available to use it. And there was also some cooperative aspects with the Russians that were included in that original program as well. So it was a very broad program that was approved by the ministers in late 1995. And we've been working on it since. We've been working on it starting very early in 1996. We signed the first major contract, in fact, in March of 96 for the Columbus module. And we've been working diligently ever since. We've been on orbit with some of our elements since July of 2000. The data management system for the Russian service module was built by ESA as part of our overall program, and that's been on orbit since July 2000 and has worked perfectly ever since. The microgravity science glove box has been on orbit since 2002. That was built in Europe. A couple of payload facilities and the minus 80-degree freezer have also been on orbit, those since July 2006, which was when we had our first increment flight as well, when Thomas Reiter flew from July until December, and came down in December of 2006 in the company of Christopher Fuglsang, who also flew to the station in 2006. Node 2 has been on orbit since the 23rd of October. That's also part of the program. The nodes, in fact, are something that we've developed and handed over to NASA in exchange for the launch of Columbus. Launching Columbus is a reimbursable function on the space shuttle, and rather than pay cash, we gave Node 2 and Node 3 to NASA as payment for that launch. So that we were very happy with the way that the node has performed on orbit since it's been up there. So quite a broad-ranging program. To date on the program, we've spent $5 billion. 5 billion euros. It's a lot more than $5 billion these days. It's about $7 billion. I told you in December it was 5 billion euros, so we haven't spent any money since December. That's what we spent to date. By the time we get our first several years of operations, our cost projections go out at the moment to 2015, and by then we'll have spent from cradle to grave a total of 9 billion euros. And that covers all of the hardware and the launches and all of the ground segments and facilities that I've described, and it also includes the agency costs as well. So the numbers that I've just given are full cost accounting type of numbers. That money's been spent very largely in industry. We're very careful in the European Space Agency to try and make sure that as much of our money goes to industry as possible. We We spend comparatively little in-house. We don't have a huge in-house effort on the things. We get industry to do the work as much as possible for us. And that money has been spent employing, therefore, over that period of time, about 5,000 engineers, technicians, administrators, secretaries, bus drivers, in industry in Europe. 50 different companies have been involved in 10 different member states. So it's a very broad spectrum of people that have worked on the program. And therefore a broad spectrum of industries and engineers that have advanced as the program itself has advanced. We get our money from our member states, but the ISS is what we call an optional program. Our member states may or may not participate as they choose. Our science program, for instance, is a mandatory program, and every member state participates in that, but it's an optional program on ISS, and we have 10 participating states in that. And the majority stakeholder, our major stakeholder, is Germany with 38% of the contributions. The French contribute 25%, the Italians 17%, and the other 7 countries comparatively small amounts. The other countries being Belgium, Spain, the Netherlands, Switzerland, Sweden, Denmark, and Norway. So again, it's all of the industrial work goes back in proportion to the contributions that are made as well, and that's quite a constraint on us. We have an industrial return policy that says what countries give us, we try and give back in work, and that makes it difficult sometimes to balance the work that has to be done. So that's the general program. Now to Columbus. As I said, the contract was signed in '96 and was signed with the what is now the Astrium company of Bremen. It's had a number of different names over the years, but Astrium is their name today. And when we signed the contract, it was based on a launch in 2002. So we've suffered a couple of major delays. It was the end of 2002. We first had 2 years of delay because of the problems with with funding on the Russian side. In fact, in the early days, the service module ended up being 2 years late on orbit. So all of the station got moved by that 2 years, we included. And then, of course, we suffered 3 years of delay as a result of the recovery from the tragedy of Columbia. So that's when the program started. What I wanted to do now is to show a little video of Columbus on orbit and give you a little Cook's tour of what the station will look like with its new module. So if we could cue in the video, please. Franco promised me that the video would come straight up when I cued it. It is? There it is. Okay. So we approach the leading edge of the station, and you see, first of all, that Columbus is on the leading edge. This is a selfish European Space Agency presentation. It didn't show Kibo on it as well. We go inside Columbus, and you see that we're 4 racks long. We're shorter than the other modules, but nevertheless we have 11 payload racks inside, which is the same as the other modules. And it's sized from a life support point of view to be able to have 3 astronauts working simultaneously inside it. It's not required that they work inside it, but it can sustain continuously 3 astronauts inside. We move out into Node 2, to which it's attached, and very cleverly, by the magic of computers, we go through the laptop into the outside of the station, and we look back on Columbus. Now we're looking in the flight direction of the station. On the outside of Columbus, on its free end, there are 4 platforms on which external payloads can be attached, and with the launch tomorrow, 2 of those European payloads will go on. The one on the top is a payload called Solar, which is surprisingly enough all about looking at the sun and studying the sun. And there's a payload on the underside, which is UTEF. It's an experiment that is looking at technology and materials that will help us for spacecraft development in the future. And so we, in good cowboy style, we ride off into the sunset and leave the station behind us. So that's Columbus as it will be in a few days' time on the station. Columbus is about 7 meters long, 4 meters in diameter. It's the same type of diameter as all of the other modules that are on the station. It contains a total of 16 racks, of which only 3 are used for systems, 11 are used for payloads, and 3 are used for stowage. 3 racks for systems is very small compared to the other racks on the station, but we've packaged the subsystems very carefully indeed. They're hidden behind all the nooks and crannies. They're in the end cones of the station, and that way we can end up with a very compact module, and therefore a comparatively light module, which means that when we launch tomorrow, we launch with 5 integrated payload racks, which none of the other modules have been able to do. And we launch with the 2 external payloads that I mentioned as well. So we get a lot of bang for our buck with the launch. It's meant that we've had to design, when I say we, our industry, our European industry, has had to design the module very, very carefully indeed, because it still has to be maintainable. We still have to give the astronauts access to all of the subsystems, but it's designed in such a way that we can launch it fully equipped. There are 5 racks inside, as I mentioned, a biolab, a physiology laboratory, a thing that we call the European draw rack, and a fluid science laboratory as well. And there is a rack that's containing a lot of hardware that's used to outfit those first 4 racks that I mentioned. We'll be commissioning Columbus during this mission, and for us, commissioning Columbus means doing the only thing that we've not done in terms of testing with Columbus to date. We are putting the principal investigators, the scientists, directly in touch with their payloads on the Columbus during this mission, during the next 2 months to come. We will check out the systems, we'll check out the interfaces with the station, but what we're really going to check out is the ability of the scientists to operate their experiment with the help of the astronauts on the Columbus and make sure they get their data down. Every element of that chain has been checked out on the ground, but the one thing that we've never been able to do is check out the end-to-end system with the vehicle on orbit, and that for us is going to be the concentration of commissioning. So we will in fact be getting science back from the Columbus laboratory within a week or 10 days of its launching, and that's something that we're very excited and very pleased about. So that's the Columbus in a nutshell. Columbus will mean that we've got our real estate on orbit. We'll be part of the on-orbit club, and therefore we accumulate the operations costs that are necessary to pay for participating on the station. And we pay our operations costs by launching and providing logistics to the station via a vehicle called the Automated Transfer Vehicle. Now, the ATV is a new departure for Europe. It's got just about everything that a spacecraft can have. It's a human-rated spacecraft. It doesn't launch with people, but it attaches itself to the station, so it's man-rated in that sense. It's got all of the navigation and guidance requirements that are necessary to get you to the station. But it's also got all of the characteristics of the most complicated of satellites as well. So it's a very complex vehicle, and I wanted to tell you a little bit about that. It also started its development in 1996, around about the same time as Columbus, but has had a rather different history. And again, if I can cue up a video, I want to show you a little bit about the mission of ATV and explain to you how the mission goes, and then I'll tell you a little bit about the vehicle itself. So if we can again get the video up, please. It's launched on an Ariane 5 and separated from its upper stage, and then it starts its long coasting period towards the station. About the first thing that we have to do, of course, is to deploy the solar arrays. It needs to have power. It needs 4 kilowatts of power to keep it going throughout its entire mission. And they're deployed, and the antennas are deployed so that we can start the navigation process. And it goes through a phasing period of quite a considerable period of time. It's about 7 days before it starts the proximity operations, those operations near the station. And there we have a very new departure for Europe, and I think a unique system as far as spacecraft are concerned as well. It's a laser-based system, 2 different types of lasers that are used to home in on the station. It's controlled by a ground center in Toulouse. It's not flown in by astronauts. This is an automated vehicle controlled from the ground, but in fact it controls itself from one hold point to another and is checked out by the ground and then given the authority to move to its next location. And the crew inside that are monitoring the approach of ATV get data, they get range, and they get range rate data as it approaches, so they can see if everything is in good shape. If they're really upset, or if they think that we're coming in too fast or on the wrong line, they do have a very, very large red button they can press to tell it to go away. We've tried to train them not to touch that button, but astronauts will be astronauts. But they can see the thing coming in and check, and they are another level of checking on the accuracy of the approach. And then it comes in and it docks to the back end of the service module using the Russian docking system. The mechanical aspect of the docking is exactly the same as Soyuz and Progress, because we dock to the same station as to the same service module port. And then the hatch is opened, and the internal transfer of cargo is performed by the astronauts that will, during the mission, slowly and gradually take the cargo from ATV in. They'll take it in when it's needed. It's not all offloaded on day one, because ATV can stay at the station for up to 6 months. So it can be used as a storage location as well. And as we empty things out, we put trash back in. A big feature of the ATV is that it can reboost the station. It can reboost the entire station, which will be nearly 400 tons by the time it's finished. So that's a lot of oomph that it needs to compensate for the decaying orbit that the station has, and that's a major feature of the ATV mission, will be the reboost. When it's completed its mission, which, as I say, is up to 6 months, it then goes into a controlled and safe but destructive, well, it's safe for everybody apart from the ATV. It's a destructive re-entry. Landing in the bits that do land will land in a broad footprint across the southern Pacific, in a very unpopulated area. We have to meet extremely stringent safety requirements, of course, to avoid damage to property and injury to people, and worse yet, death to people. So it's a very controlled re-entry on a well-known trajectory, independent of the fact that it can have had system failures. Of course, we still have to be safe even with system failures. So it's quite a complicated mission. The vehicle is about 10 meters long. It's a huge vehicle. If anybody has traveled to Europe and seen double-decker buses in Europe, this is a double-decker bus would fit inside the envelope of ATV. It's a very big vehicle. It's also about 4 meters in diameter. It has the same primary structure as Columbus, for instance, and the same primary structure as the nodes, and the same primary structure as the mini pressurized logistics modules. So we've been able to utilize common technologies throughout the developments. It has a front end, which is the cargo carrier. It doesn't separate on orbit, at least we hope not, but just for the purposes of demonstration. It has a cargo carrier which is about half the size of the Columbus module, so it's the equivalent of 2 racks long, inside of which is the pressurized cargo. And on the back end of the integrated cargo carrier, as it's called, are fluid tanks that can contain oxygen, they can contain water, they can contain fuel for the Russian system, for the Russian attitude control system, which is transferred to the station during the mission. Behind the cargo carrier is what we call the spacecraft. And in the front half of that are all of the avionics, all of the power distribution systems, the computers, the the equipment that monitors all of the navigation equipment that's at the front end of the vehicle, and of course the 4 solar arrays are deployed from that. And behind it is the propulsion section, where we have up to well, there are tanks that hold several tons of fuel inside there. So it's quite a large vehicle, and one that has taken a long time to produce. I mentioned that it has the Russian docking system, and that we've developed for ourselves the navigation system that goes with it. It is a logistics vehicle. I mentioned that it carries different kinds of cargo. The dry cargo inside the carrier is crew supplies, food, clothing. It's system equipment, spares for failed equipment. We're in fact carrying some spares for Columbus up on the first ATV mission. We haven't had any failures yet, but it's so that we've got pre-positioned spares. And it carries science as well inside the module, of course. In terms of fluids, it carries the fuel, as I mentioned. It carries both American and Russian water, which is quite interesting. You'd think that water was just some form of mixture of hydrogen and oxygen, but there are 2 different specifications for water, depending upon what kind of crewman wants to drink it. The interesting thing is that both the American water and the Russian water is produced in Italy. So if you can work that out, please explain it to me. And it can carry up to 4,500 kilograms of fuel for reboosting the station. So it contains a menu of cargo, and on any one mission it can carry up to 6 tons of usable cargo to the station. So it has about 3 times the capacity of a Progress. Not that we're competitive, of course, but 6 tons of useful cargo goes up. It's launched on a special version of Ariane 5. Ariane 5 is normally used to launching commercial satellites, generally to geostationary orbit, and has launched up to about 11 tons so far. But ATV is 20 tons, and therefore we've had to reinforce the top end of the Ariane to carry the ATV, and it also has a special upper stage for putting us into the right initial orbit. And the mission is controlled from the control center in Toulouse. The first flight of ATV is a special flight. We've not done a qualification flight of it, so the first flight will be a demonstration flight followed by an operational flight, all in one go, which is a bit gutsy. So we'll do what we call 2 demonstration days, and we will preface that even by doing a collision avoidance maneuver. So we fly into orbit, and when we're still several thousand kilometers away from the station, we demonstrate that ATV can be taken off of its trajectory and taken out of the approach to the station. This is something that's normally only done when you're very, very close to the station. It's a safety feature of ATV for when you're very close to the station. We don't want to demonstrate it for the first time when we are very close to the station, so we'll demonstrate it when we're several thousand kilometers away. We'll then go into what we call demonstration day 1, where we fly from the first hold point, which is about 37 kilometers away from the station, into a position that's fairly close to the station, some hundreds of meters away, during which time we'll be under relative GPS control. And we'll demonstrate the ability to fly into that hold point, stopping it at that hold point, checking it out with the ground center to make sure that everything is okay, and then we will fly back to the start point of that mission. And then we'll stop there for a couple of days, and we'll look at all of the results and see if ATV was working the way that it should have been working. Then 3 days later, we'll do demonstration day 2, which takes us again to that hold point, and then to a point that's just 12 meters away from the station. Again, we'll hold, we'll retreat for a few meters, we'll go back to that hold point, check it all out again to see if we're okay, and then go back to our start point. So again, these are the things that you would normally do on a qualification flight, so that's our qualification flight. And then we have enormous meetings with everybody and his brother in America, in Europe, in Russia, to check if we're all really happy, including the crew, and then we will go in for the rendezvous to the entire station. So that's the mission for Jules Verne. And what I can tell you today is that mission will start sometime on the night of between the 7th and the 8th of March. It depends which continent you're on as to whether it launches on the 7th or the 8th of March, so it's around about midnight, 1 o'clock in the morning. And that launch has been fixed today by a meeting with the launcher authority and with ourselves, and has been communicated to the space station partners as well. And that will be our first mission of ATV, which should then last out until about August time. So that's Columbus and ATV. What I'd like to do now is bring us back a little bit to Columbus and hand over to Michel Tognini, who, as George said, is the head of the European Astronaut Centre. He himself is an astronaut. He's flown twice before. He's flown once to Mir in 1992. He was there for a couple of weeks, I believe as a Kness astronaut in those days, and then once on STS in 1999 for a mission there. So, Michel, let me pass over to you, and you can tell us all about Hans and Leo.
Thank you, Alan. Good afternoon, everybody. So I will explain a little bit about the flight for the astronaut. The STS-122 will have 7 astronauts to go up. 2 of them belong to the European Space Agency. Hans Schlegel is a German astronaut from ESA. He already flew on the Space Shuttle in 1993 to the mission STS-55, mission called Space Lab Mission D2. It was a mission of 11 days. Then after that, from 95 to 97, he trained at GCTC in Russia to train on Soyuz and Mir for the German-Russian mission Mir 97. And in 98, he joined NASA for the training MSTA to be a mission specialist at NASA. And in 2006, he was assigned to this mission that will fly tomorrow, STS-122 or 1E. During this flight, Hans will have many tasks. The most important are he will be a member of the rendezvous team. He will perform the EVA. He will have 2 EVAs together with another crew member. He will have the EVA 1 and EVA 2 to perform. And he will have the Columbus vestibule setup to perform. And also he will support the Columbus activation outfitting. Concerning Leopold Eyharts, he is also an astronaut from European Space Agency, but he's French. He already has a flight experience. He flew on Soyuz and Mir in 1998 in the framework of CNES. It was a 3 weeks flight at this time. Then he started the training also at NASA as a mission specialist. And in 2004, he was assigned as a backup of Thomas Reiter for the mission that was joined between Expedition 13 and 14 in 2006. The mission was called Astrolab, you might remember. And in 2006, after this backup position, he was assigned as a prime crew flight engineer 2 on the ISS Expedition 16. During the flight of Leopold, that will be a little bit shorter than what we wanted, he will take care mainly of the Columbus activation outfitting, setup checkout of the ESA payload facility, and also the commissioning of Columbus payloads. He will support the SSRMS operations, the robotic arm of the space station. And after the docking of the next mission 123, he will participate in the checkout of the SPDM, which is a special purpose dexterous manipulator. We can get the flight, the second slide. The second slide will show you the flight that we did last year. We prepared all the flight on Columbus by different missions. The most important one was the one of Thomas Reiter. It was the first mission when we had a crew of 3 after the accident of Columbia. It was a mission made in July 2006, launch on Shuttle, return on Shuttle together with Christer Fuglesang. And Christer, present here today, flew also on Shuttle for an assembly flight with EVA, and then Paolo Nespoli flew in November last year for a mission of assembly of ISS with EVA. What the astronauts are doing this week, they arrived Monday from Houston. They were in quarantine already starting Thursday. They are in a good spirit. This week they had the fit check of the spacesuit. Some of them flew the STA, which is a shuttle training aircraft, and some of them flew the T-38. They had some briefing, especially the briefing on the weather, as you know it's a concern for tomorrow. And they did also some training on rendezvous, robotics, with the DST simulators. They had some briefing on the EVA for their flight. They did some exercise, and they will meet their family tonight if everything is okay. And that will be the last thing to do before the flight tomorrow. I give you the floor, if you want. Alan?
Okay, thank you, Michel. Just a few wrap-up remarks. We've given a lot of information about the crew and about the vehicles and everything, which sometimes might sound a little dry, but it would be sad not to mention the fact that we're really, in fact, rather excited and extremely proud and very happy to be where we are at the moment. From October through until March, we'll be launching about 45, 47 tons to the space station. It's a huge amount of hardware to launch after 10 or 12 years of development, and there's an awful lot of people in Europe that are very proud to be a part of that. We'll own a part of the station. We'll have the rights to have our astronauts flying on there to perform the iterative science that they can do so well, and to be the icons for the youth of the future in Europe as well, which is something that's quite important to us. So we're really looking forward to getting Columbus on orbit, to becoming an on-orbit member of the Space Station Club with our own module, and we hope that those that are lucky enough to have managed to come here, but also those that will be watching at home in the various European Space Agency centres and in the various industries that will be following the mission, that they're going to share in the joy and the happiness and the pride that we're all going to have with tomorrow. So with that, I'd like to thank NASA for giving us the opportunity of talking with you today, and I hand you back to George.
All right, thank you, Alan. We're ready now to take questions. Please give your name and affiliation when the microphone comes to you. All right, we'll start here in the front with Patrick.
Patrick Peterson with Florida Today. Do you have plans, how many ATV flights per year do you plan to fly, and do you have plans to convert it into a manned vehicle with re-entry possibilities?
Okay, as I said, ATV is a way in which we pay our membership fees for the station. So we've negotiated with NASA a number of ATVs corresponding to another number of years of participation. And our obligations out until 2015 are satisfied by flying the first ATV, Jules Verne, plus another 4. So there'll be a total of 5 flights that will satisfy our obligations out until 2015. What we're certainly hoping and even more expecting is that the station will go on beyond 2015, and we will then hopefully continue with our participation on the station, and that will mean another ATV flight roughly once every 2 years is about what equates to our dues. Can ATV be used as to develop a manned vehicle? Yes and no. I mean, in principle, you can think of removing the cargo part of the carrier and putting a capsule on top, putting men on it, and sitting it on top of Ariane 5 and launching away. But frankly, that would be rather an inefficient human spacecraft, because this is designed for a particular mission, largely associated with reboosting the station and carrying 4.5 tons of fuel. But the technologies that have gone into ATV, the rendezvous, the navigation, the man rating, the ability to dock, the ability to control from the ground via our own ground station, those are the building blocks that would enable us to evolve a human spacecraft from the work that's been done on the ATV. So the fact that we've done ATV puts us in a posture to be able to do human space transportation. It wouldn't be a direct derivative, though, of the ATV as we know and love it today.
Further questions? Irene.
Thank you. Irene Klotz with Reuters for Alan Thurkettle. Could you estimate the number of scientists that are involved in this startup work with Columbus? How many people will be on the ground, and are they all working from the control center, or does the Columbus module have the ability for scientists to work at their at their home institutions or I guess even their homes?
That's an interesting question, Irene. I'll have to get back to you as far as the number of scientists is concerned. It's something I should have thought of, but I don't have the numbers, and I don't want to try and guess one. But I'll get that number back to you. There are lots, though, and they won't all be working at the Columbus Control Center. In fact, relatively few of them will be. We have a distributed ground system as far as the scientists are concerned. And we have what we call user support operation centers. There are 9 of them scattered throughout Europe, from Scandinavia down to South Italy and East and West as well. And the users, the scientists themselves, will largely be based at those USOCs, as we love acronyms. And they will work from them and from those USOCs, and they will communicate via the control center through to Columbus. So it's a distributed system, but it's a real-time system for the scientists.
Okay, we have a question back here.
Leo Enright with Irish Television for Alan Thurkettle. A midnight on the 7th launch, does that put docking around the 22nd? And are there any implications for STS-123? Is there going to have to be some juggling if there's a delay on the 123 launch?
Yeah, I should have mentioned that ATV is an integral part of the space station system. It doesn't just fly when it feels like it, and it certainly doesn't dock to the station when it feels like it. It indeed has to fit into to a traffic pattern, and this spring the traffic pattern is quite substantial. I heard the ISS program manager last week describing the job of the Mission Operations Directorate as being akin to air traffic control. Because we've got Progresses, Sawyers, Shuttles and ATVs going up in the space of, I think now it's less than 2 months. Launching on the night of the 7th and the 8th, we'll be targeting for a docking at the end of March, the very end of March, about the 30th. And we have a window that extends out until the 5th of April, which is a window that satisfies the ATV constraints, which has got certain sun angle requirements and that sort of thing. But it also satisfies the traffic constraints and the station operational constraints as well. And we will wait for 1JA to have departed before we start doing our demo days. We were trying to look at a mid-February launch, but we've decided to add more robustness to the launch schedule and get a date that we're truly confident in. If we'd launched in mid-February, we would have docked before 1JA, before STS-123. But we'll need to get final confirmation from all of the partners. But now I think with us launching on the 7th, 8th, the 1JA will now go on will target to go on the 11th of March, and we'll have its mission finished before ATV starts its docking procedures.
All right, further questions? Here in the front.
Yes, Ethiopia Space Information Center, Belgium. In the case of the revolutionary laser systems did not work properly, is it possible to fix the ATV on the station with the Canadarm? Is it possible?
No, it's not possible. We don't have grapple fixtures on the ATV to enable that to happen, for one point. Secondly, the docking system of the Russians requires quite a high relative motion, whereas berthing requires more or less no relative motion at all. And the docking requires high relative motion in order to activate the spring system. And the third thing is the Canadarm can't reach that far. So apart from those three things, it would work quite nicely. But we have no need, I'm sure, for such a backup for a number of reasons. First, you have two separate systems as far as the laser are concerned. The primary system, which is a videometer, is itself redundant, so it can tolerate failures and still operate by itself. It's monitored by another system, which is called a telegoniometer, a horrible word, that is a backup system that monitors the videometer, and if the videometers are not working at all, it can take over. And finally, there's a further backup system in that we have the Russian Kurs antenna, that is also checking what's going on. Although I don't think we want to dock using Kurs alone, but we have so many ways of getting there that I don't think we need the ability to berth as well. And if all else fails, then we have the ability to return to a hold point and check out what it is that's gone wrong, and send up some software patches. Hopefully it wouldn't take more than that to correct whatever the problem was, and try again. So there's an awful lot of redundancy in an ATV.
Any more questions? All right, let's come back here right behind Irene.
Hi, Claudia Di Giorgio, Le Scienze. I would like to know how much is the cost of the launch of ATV, and if there is some kind of insurance, and if so, how much is the insurance?
We have a contract with Arianespace to launch a number of ATVs, and when we signed that contract, we were expecting to launch a lot more ATVs than we're currently expecting to launch. So in fact, we have to renegotiate that launch contract, and in renegotiating it, the price per launch is going to change a bit. But it's the order of magnitude of 150 million euros, the price of the rocket itself. You don't get the ATV for that; you just get the launcher itself. We're not insured. We decided not to insure, firstly because it costs rather a lot of money. Secondly, if we're insured if there's a launcher failure. That's part of the normal launcher services. So if there's a rocket failure, then we get a free launch, if you like, a free relaunch. But if ATV were to fail, we thought that it would take us so long. Generally, when you get a serious failure like that, you're down for 3 years. And if we had to wait 3 years, chances are that it would cost hundreds of millions to do the fix, and were we really likely to go through with that? On the other hand, the money that we wanted to that we would have been paying for insurance, we decided we could maybe obviate the need for insurance by doing more robust testing, more robustness testing, putting in a little bit more redundancy here and there, and making as sure as we could that the ATV didn't need to be insured, i.e. that it would be successful. So it's not insured now. Yeah.
Okay, Dave.
Hi, this is Dave Mosher with Space.com and Space News. This is for Alan. As an American press member, I'm not sure I grasp the amount of excitement that Europe might have for both Columbus and this ATV that's going up. Can you sort of describe how a common European citizen might be excited about this mission, and also from an administration standpoint?
Yes, it's difficult for a phlegmatic Brit to try and communicate excitement and joy and happiness. You know, we're quiet, gentle folk. The further south you go, the more fun that people will be having. But a lot depends on the real involvement. I mean, a lot of people will be watching on TV. A lot of people will be following it through the schools. A lot of people will be following it through the websites. I mentioned that the 5,000 people have worked on it. They've got families, they've got friends, and it's known about in the local presses here, there, and everywhere throughout Europe. But I think the real focal point for the excitement will be, well, maybe two. The launches themselves, which are always very spectacular, and then having astronauts on board. They're a focal point of not just of excitement, but of inspiration as well. And for the European Space Agency, of course, it's extremely important after 12 years of working on a program to have something that gets launched. It'll be nice to be part of the European Space Agency. We've been part of a European ground agency for a long time, as far as space station is concerned. And I think for this year we have 7 or maybe 8 launches to do for the agency throughout the year. And at the end of this year, we have what we call a ministerial conference, the same type of conference that approved the space station program in '95. We go back to our ministers again to ask for fresh money for new programs, and that's another part of the excitement. If we've got the successes of all of those launches behind us for this year, and the proof that the investment that the ministers and the citizens have made over the last 10 years that proof in orbit, then we get the chance to do a whole raft of new programs as well. So it's many different facets, but there's going to be a lot of pride, a lot of people with good feelings in their stomachs when these things go up.
Further questions? We have one right here in the front.
Rob Coppinger from Fly International Magazine. I've one question for Michelle and three for Alan. Question for Michelle is how often have we seen a shuttle flight with two ESA astronauts on? And maybe this is the first. And my questions for Alan are, the delay to the 8th, when the launch window originally was started with the 22nd, is that because is that there were some issues with simulations on the ground control centres? So is there further testing to be done with the ground control centres to make it more robust? When are you going to name the next ATV? And you've mentioned before in other briefings that you want to purchase time, extra space station time from other partners. Is that the Russians or somebody else?
Okay, so for the flight with two ESA astronauts, it's not the first time we had that in history. I would like to mention the flight on Hubble, where we had Claude Nicollier and Jean-François Clairvoy involved. Before that, we had a tethered mission, tethered satellite with Umberto Guidoni and Maurizio Kelly. And also, just recently, last year, we had Christoph Fuglesang and Thomas Reiter, not in the same mission, but coming back together to Earth. And so it will be the first time, and I might forget other missions of this type.
As far as the movement of the launch date, it's a mixture of things. Movement of the launch date of ATV. It's really to add a final element of robustness to the availability of the entire system. The spacecraft itself is complicated. The ground segment is complicated. It's the first time that this particular version of Ariane 5 will have flown. We had a meeting with all of the stakeholders today. Everybody confirmed, the flight segment confirmed that they're fully qualified, the hardware's in good shape, it's fully loaded, all of the fuel and the dry cargo, the water, etc., is on board. It's ready to move in the final stages of integration with the launcher. The launcher qualified that it's ready. It's been through its qualification program. It's going to move to its final assembly building in the next week or 10 days. The ground segment is the ground segment. It's ready. You give a ground segment another 3 weeks, and they'll do 3 weeks more of simulation and testing, and they will be better as a result of it. We wanted to ensure that we'd got spare weekends between now and the launch. We deliberately did not want the crew at the launch center, except during the countdown itself, to plan weekends. We want to keep the weekends as margins in case something goes wrong, because we're doing so many firsts all in one go. So it's really a mixture of all of those things, and it's a matter of prudence. Now we didn't want to be too prudent, because if we go much later, which we could easily choose to do, then we'd have difficulty in docking with the station. So we wanted to make sure that we could meet the window at the beginning of April. So it's for all of those reasons, not just one thing. We will start the process of naming ATV2 once we've seen ATV1 get to the station, once Jules Verne gets to the station and dock. We haven't yet decided how we're going to go about determining a name, whether it'll be a competition or whether we'll be a little bit less heroic than that. And your last question was related to the the extra flights. Once Columbus is there, we're entitled to one increment flight every 2 years, so 6 months every 2 years. We're in discussion with the Italian Space Agency, who own a number of increment flights themselves, through a bilateral conversation with, a bilateral arrangement with NASA, and that we hope will give us some more increment flights as well, and we'll finish those negotiations, I guess, in the next few months. And also we'll enter probably into some discussions, yes, with the Russians to see whether they do indeed want to have their three permanent people on board all of the time or not. They're the only ones that you can buy something from. I don't think NASA will be selling any of their flights to us at all.
Right. Irene, your follow-up will be the last one because we're out of time.
Irene Klautz with Reuters. Alan, you mentioned this a little earlier about the proof, and aside from the number of Brits who crack a smile, do you have some measurements over whether this whole investment and this time that Europe has put into this project is successful? In other words, how will you know if it's all been worthwhile?
That's really quite difficult to answer. The trite answer is that in about 4 or 6 weeks' time, we'll have commissioned Columbus. We'll have started getting science down. We'll have started putting a smile on the faces of even the scientists, even British scientists, and getting the results back that all the investment has been there for. But space exploration in general is not quite like that. It's not a road to Damascus thing. It's something that builds up over a long period of time, and we'll see it by youth going into science and engineering in their education. We'll see it with the improvement of life on Earth, because the medical experiments that we're doing are finding and helping to cure some of the diseases, or generating the pharmaceuticals that will help the health of people. We'll see it by the development of water treatment improvements that we hope to be able to demonstrate on board Columbus, that hopefully will help in water treatment in some of the underdeveloped countries. We'll see it in the materials that get developed that improve aircraft engines, etc., etc. You see it in that sense. It's not a shining flash of light that yes, it was all worthwhile. We're into a research and development thing, and the payback of that is something that occurs over a long period of time.
All right, that's all we have time for. Our next STS-122 event will be launch coverage, which begins with tanking at 5:15 a.m. tomorrow morning. Thank you.
Next slide, please.
personnel reporting DC road safety facility firewall here in the at 2015 hours. I checked it on Pad A. All personnel reporting the final debris walk down.
Attention all personnel, launch of STS-122 is scheduled for February the 7th, 1445.